for higher studies. If I go for a higher study, spend 4 years in academia, when I come back, all my colleagues who had gone to sort of industry would be really tech leads or tech architects, earning more, but most importantly, really experienced. So I come back, come out, and then where do I go? Do I have to the only option being an academic, or do I have other options? So that's where I think the problem is. But with this approach, where we do a Scrum style research, and then we have even started doing Scrum style assessments in our assignments, in our teaching with sprints, then things have changed. And then every PhD students work on 3 or 4 projects, real projects. But the difference from an industry consultant's approach is that we bring in cutting edge research, new innovations into our projects as well. Right, moving on. Do still have a few minutes more? All right, I'll get on to something. So that's our research center, but it was important because that will give you an idea. When people ask, how is it that you do all these projects with about 10 PhD students, and we have about 10 research assistants and 6 full-time academics in the research center. So it's a reasonable sized research center, but we do quite a large number of projects. Okay, now I mentioned before that our approach to AI is different, and it's important for me to talk about that and try and get that message across before I hand over to the others who will talk about specific projects. All right, so we're supposed to, we are living in a digital world, and there's this term of big data. So what is big data? Why do we call this a digital world? Now, that picture says a lot, because there's a lot of information being created. Unlike in the past where we collected or we generated data when we have something to do in mind, now data is being generated whether we particularly want it or not. So, but it's not only about data being generated by sensors to wearables and IoTs and so on, but there are machines, that's their cars, talk to each other. There's in smart homes, different gadgets talk to each other. And this comes to the next level of generates an environment, like in a factory settings. There are cyber-physical systems. So why do we have this? And it's important to understand what is happening here to be able to use artificial intelligence or the next generation, or develop next generation of artificial intelligence. So what we have here, what this picture is trying to tell you, is that we have the environment, the living, the real environment, the physical environment. And we as humans or any animal, we are born with this ability to live, exist, breed, and then of course move on in this environment. We don't need AI or any other tools to do this. Right? Now, all other animals are happy with that, but humans has never been satisfied with that. So we want more from this. That's why we have started developing tools, technologies. So without going into too much detail, we have come to a stage that we are not satisfied with just having tools, because the tools don't have the ability to talk to the environment and sense the environment. We are born with that ability, but we build tools, but we can't give the tools that ability. That's where AI has come in, and that's how we should think of AI. So why do we need AI? Is that we want the tools to do things and interact with the environment by themselves. That's where AI has come in. Now, how do we do that? It has become possible to think in this way, because that the outer layer in that picture is the digital representations of many things in the environment is being created. The audio to the numbers and so on, images to videos, not only are these being created, we use this in our day-to-day life, but also things like social media. With social media, so it's not only about things, objects in the environment, but we are leaving traces of ourselves, our opinions, our behaviors, our sentiments, and even our deeper emotions out there in digital form. So we can consider it as there is a digital version of the natural environment. At least most of it is currently being created. Now, if it is in digital form, then the machines, the computers, especially the right type of AI, can read this and interact with this. So that's why we have to start thinking of data as digital representation of many things in the environment to start developing the type of AI that would be useful for us in the future. Now, what we have at the middle, or the right at the center, that's a human, and then the term cognition. Now, our research center data is called Data Analytics and Cognition. It's broader than artificial intelligence. Now, what is cognition? Cognition is made up of all these things that I have listed there, from understanding, intuition, learning, insight, perception, and so on. So these are all things that we have defined to try and label different abilities, things that we have. We've created these labels or definitions. What we need is artificial intelligence, or the type of AI where the algorithms can be inspired based on our understanding of ourselves, which can then interact with the digital version of the natural world. That kind of AI is now possible. Now possible because the data is available, and of course the AI can be built because the technology is available. But there are certain things that are lacking, that are problematic with the traditional AI that people use, traditional machine learning and AI. That's where there are two key types of AI that we focus on. One is that we are working on the core of our algorithms are based on what we call the self-structuring AI. Currently, artificial intelligence has to be built to suit a particular problem. So when you say build, the network size, the network architecture, the number of nodes, and so on have to be predefined and pre-built. But self-structuring means it's like a baby. You can create an AI baby that will then grow to suit the problem where you as a human don't define the problem, but the AI will be built where it will look at the data, which is the digital version of the environment, and create itself to the right side, the right shape, and so on. The other side is that which is less explored, but becoming a very popular, very important aspect, that type of AI is it's called effective computing, where we were using the traces we humans leave in digital form. We can capture our behaviors, our opinions, and especially our deep emotions. So there are two different types of AI with which and bringing this together, we can build, really make use of this, the digital information that's available. So that's very basic, I guess the philosophy behind the type of artificial intelligence that we have created over a decade, even from my long time ago, from my PhD, but which is being taken forward by this very clever group of people, and being built upon to really make use of the information that we are creating. I don't think we are alone. You don't have to be worried, because we still have a long way to go to come to that level. So, two types of AI. Perhaps one word is inorganic type of AI, the machine type of AI, so the digital representation of things that are objects and so on. And then the human aspects. Now, I'm not sure how, well, I guess many of you are familiar with the two key basic types of learning paradigms, the supervised learning and the unsupervised learning paradigms. Now, supervised learning has been the most popular, most widely used artificial intelligence, and what is required in supervised artificial intelligence is that you need a data set that's pre-labeled. So you need to have a data set that represents the past, and we have to know the past where you have the labels, or we can call the target value. You build an AI and train it from past data, but make the big assumption that the future is going to be like the past, and then you expect the AI to classify, predict, and tell you what you require based on the past. Now, that type of AI is getting obsolete for obvious reasons. Think of the smart digital world, the smart homes, the smart environment that we are talking about. Data is being generated in large volumes, and with such volatility, there's such frequency, and there's data of diverse nature being created as well. And we want the data to be processed and outcomes from our AI real time or near real time. So waiting for past data that is pre-labeled, we call it post-mortem type of analytics. Now, days of post-mortem analytics is over. We can't be satisfied with that. That's where the problem comes in. So that's a major problem. And also because the things change so fast, saying that the past data, an AI trained on past data being used for the future is not going to work anymore. That's where unsupervised learning has become so important. So the core of our algorithms are based on unsupervised learning, and the most popular unsupervised learning technique is called the self-organizing map, which I will not go into too much detail, but perhaps many of you are familiar with self-organizing map. But also we worked on fusion of information, combining information together from multiple modalities and sources, and also something called incremental learning. Incremental learning is as things change, the AI has to adapt itself. So those are key important things that the new AI must be able to handle. Then, of course, as I mentioned, the human aspect, making use of human aspects, which Achini will talk to you more about. So our research center calls these the two key pillars of our research. One is the self-structuring AI that can, starting from an unsupervised base, adapt itself and grow and change to changing representation of the environment. Other is the effective computing. We build algorithms with that and then transform these algorithms to tools and building blocks with which we build technology platforms. Now, time? 5 minutes, okay. Right, so that's the philosophy, the thinking behind our AI, and I would even call it rethinking artificial intelligence. But before I hand over to Rashmika and talk about the practical applications, I will just very briefly say the self-organizing map, for those who, just to give you a very brief idea, looks like that. That's where there's input and output layer. So it's unsupervised learning, so you don't need pre-labeled data. So what's on the right, to your right, is what it looks like. So once you send in the data, it will automatically by itself group the data into a two-dimensional representation of its contents. So in this case, it's information, either textual or other form, which describes certain fields. And you can see that the medicine, physics, and engineering, and so on, those are labels that we can provide later to say, okay, these are, but the more important thing is that the maps will be created in a form where very different things will be far apart and things that are close by be together. Now, this is the standard self-organizing map, but we work with something called the GSOM, or growing self-organizing map, where it starts with just only 4 nodes, while the standard SOM has to start, you have to define the rows and columns or the size of that network Instead of that, we start with a very, very small network with 4 nodes, and as you input data, it will grow to arms and legs and so on to suit the data better. So for example, here the fish, birds, and mammals have basically dragged the map and grow to a different shape, which is more suitable for that kind of data. So in terms of the other, so using this technology as the core building block, we have developed incremental learning techniques to handle the volatility of the data or the changes in the data, and also distributed learning and scalable algorithms to handle big data, and then the fusion techniques so that multiple data sources can be brought together. Because it's not just a data set, that's what you have to understand. Because data is a representation of our environment. So if you just work on one data set, say if it's a video, without the audio, you are only going to get one aspect or capture one aspect of that. So the result, the outcome that the artificial intelligence, your AI is going to give you is purely based on the video side of things. And so that's where fusion algorithms, the type of fusion algorithms that we developed are important, because we look at a scenario, so our algorithms can we are trying to capture the situation rather than just one aspect of the situation. And the best example that what I always tell people is that think of watching a horror movie without the audio. Right? There is a big difference. When you switch off the audio, you're not going to be very scared because that feeling of being scared comes to you while watching that only when you have the audio as well. So what we are trying to achieve is it just the things, whatever that you see, or is it only if it's only the audio, you're not going to get that feeling as well. So, but together, it's together in fusion, it's creating something, this fear inside you. So that's what we need to be able to, not to scare people, but that's what we have to be able to capture. And the current AI cannot do that. That's why we have developed these techniques. So since I only have 1 minute or so, I will just very briefly, without going into too much detail, don't worry about all the text there. So what we have done is develop techniques to develop what we call the latent representations of the data. So we capture or we collect data about so many different things in the environment. And without doing the traditional thing of taking each individual data set and working on that and analyzing that, what we do is we build these the self-organizing map-based latent representations of the environment based on set. So there will be the videos that are captured, the audio sides, and any other as well, any sensors, any wearables. All that information is represented and continuously updated. So Rashmika's PhD, and based on a number of previous PhDs, is continuing to build that. So the digital representation of the environment is there. So the AI that we build can talk to this. So just like an animal or a human, feeling, sensing, and then either running away from something dangerous and so on, the AI can get a sense of what the real environment is by communicating with this digital latent representation of the environment. And that latent representation is continuously being updated. So that's what here we have applied this to very different. So what we do is, as we develop this technology, we work with so many different domains and people. So this is with a leading neuroscientist. And she's an expert in post-stroke therapy. So we have helped her to identify when a person recovering from stroke should be given therapy. So at the moment, they get therapy, treatment or therapy on 7 days, 30 days, and 1 year, and so on, mainly because that's the mean and that's administratively easy. But the best impact of the therapy is separate, different for each individual. So we are helping them to identify based on a number of different tests and the background of this individual, gender to many things, of the culture, the type of environment that he or she lives in, this is the period where the therapy treatment will have the best impact. So that's an example of AI helping in this case neuroscientists to provide better post-stroke treatment. So incremental learning, without going into too much details, so what we have done is things that adapt. So I'll just explain what that right side, the blue colored diagram is about. Tweets. So Twitter, we have used our incremental learning algorithms based on the self-organizing maps and to separate massive volumes of tweets into topical pathways, because there's so much things, garbage and interesting topics in tweets, but this is unsupervised. You can just feed in this into our algorithms and it will automatically separate into pathways based on the topics of discussion, and it will continue to monitor those topics. Now this was initially developed as part of our those defense and national security project. Very interesting, and so this is about Obama. I'm not sure you can see it, but not only did it capture at that time, the internal issues that Obama had to the ISIS and so on, other issues, but also there was a little stream about his personal life, the daughters and the dogs and so on as well. So this was automatically separated into these. So it can